Good evening, everybody. Welcome to week 2 of Lambda School's Introduction to Web Development. My name's Diandra Ryan Moss. I am your instructor, and as always, I am teaching you guys live from Bisbee, Arizona. So thanks to everyone who's joining me here in Zoom, and to everyone who's watching this after the fact in YouTube. So last week we had a lot of fun looking at all the basic pieces of web development. We took a look at HTML, at CSS, and at JavaScript. Tonight, to start off our second week, we're going to do a quick review of everything that we learned last week, and then we're going to move along to JavaScript and focus on JavaScript for all 4 nights this week. So tonight, our topic of interest is JavaScript functions. So we've seen a few of those in the form of methods already, but we're going to see a lot more examples of how to use and even write our own functions tonight. Before I get into screen sharing and doing that review and talking about functions, I want to talk to you a little bit about Lambda School's main curriculum. So if you're interested in attending Lambda School's main curriculum, it is a 6-month course in which you learn all about web development and computer science, preparing you for a job on the field. So the main course does run full-time. It's technically a little longer than 6 months because there are a few breaks in there. And as well, for those of you who are interested in keeping your job and attending Lambda School while working, we do offer an evening and weekend course, a part-time course, and that runs for an entire year. So if you're interested in learning about the start dates of those or even getting started on applying, you can reach out to Karen Zachary in Slack. And as a reminder, we do offer a deferred tuition program, which means that you can pay $0 upfront to attend Lambda School. How the deferred tuition works is that you start paying your tuition only once you are hired. So once you have gotten hired in a job making $50K or more in the programming industry, you will start to pay Lambda back your tuition in proportion to what you're making. So if you only are making $60,000, you'll be paying a smaller amount of tuition. If you score an awesome job where you're making 120 out of the gate, doesn't happen very often, but also not impossible, then you might be paying Lambda a little more, though we always cap that at $30,000. So one thing I did want to talk about in particular is this idea of who is Lambda School for? What do the Lambda School students look like? What type of qualifications do you need to attend Lambda School? And I actually like to start this by telling you a few misconceptions that people have. So the first misconception that people often have is that you need to have some sort of technical background or technical experience, whether that's formal credentials or just a lot of knowledge. And that's actually false. In terms of formal credentials, if you have some sort of STEM degree, and by that I mean if you have an engineering degree, a math degree, even a computer science degree, I'll be honest, that is a leg up. That's probably going to help you score a job when you finish Lambda School, and it might help you score a slightly higher paying job. I'm not saying that that means that you deserve that higher paying job, but I'm just trying to get real here. It will probably help. However, it is not necessary. We have people go through Lambda School who have no college degree. We have people go through Lambda School who have a PhD in something completely unrelated to anything technical. We occasionally have people go through Lambda School who had a GED, they never even finished high school. It turns out that formal credentials are not actually proportionate to your ability to code and learn or your intelligence. Imagine that. So we are far more interested in those things. Admittedly, the world likes to obey by its formal rules, so that means that if you do have those formal credentials, you might have a leg up, but by no means is that an inhibitor to you entering Lambda School or getting hired after Lambda School. The tech industry is a very open-minded field that tends to be most interested in what you know rather than what your sheet of paper says. So something to just let you guys know about, because I know that's a big question lots of people have. The other question, which I already sort of answered, is you don't need a ton of money to attend Lambda School. Admittedly, you're probably going to have at least enough in savings to support yourself for 6 months or so while you attend Lambda School. But beyond that, you don't need to have $20,000 sitting around to attend Lambda School. We wanted to set it up in a way where you are only paying us once you have that influx of money so that you're not going broke just trying to get through the door. Beyond that, there's also the location question. I will say that admittedly, if you are outside of the US, there are some extra hurdles that you may face when attending Lambda School. Every situation is a little different, so if you are an international student, please talk to Karen Zachary about what those are. But if you're in the US, it's usually pretty straightforward. As long as you have a good internet connection, as long as you can be here and attend Lambda School 5 days a week, as long as you are dedicated to learning this material, then we want you in the program. As far as the technical knowledge you actually need to attend Lambda School, that's what this intro course is for. You don't have to have a ton of coding experience to be admitted, but you do have to have some knowledge. And essentially, if you have gone through this intro course and you're feeling pretty good about it, you're probably at that technical level where you're ready to take that Lambda challenge and get started on our admissions process. So I know that can be a little more of a intense ramp up for those of you starting from zero, but it is doable, and I've seen students do it again and again. For those of you who do have some programming experience, this intro course will probably serve as a little bit more of a review. So I hope that gave you guys a sense of what kind of people attend Lambda School, what it takes to get into Lambda School. And of course, if you are interested in getting started with that admissions process, Karen Zachary is the person to talk to. So that is all I have to share with you guys about Lambda School's main curriculum. It's now time for us to shift focus over to doing a quick review and then talking about functions. Sorry, trying to hydrate. Okay, so I'm going to share my screen and we'll do a little review. As a reminder about Zoom etiquette, please ask your formal questions in the Q&A. However, as you guys have probably noticed, I do try and keep an eye on the chat channel, and I'll be asking you questions to reply to in the chat. So, all right, let me share my screen and we can get going. Okay, so here is, I've pulled up CodePen. Do you guys remember CodePen from early last week? We're not going to really be using CodePen for the rest of this course, but I just have it up as a little guest star for the beginning tonight so we can do a quick review of HTML and CSS. So up in CodePen, I've pre-populated it with some basic HTML and CSS. You can see up here in the HTML window, I have a div box containing quite a few elements. I have this header at the top and 3 paragraphs below it. So there's just a couple examples of some of the elements we learned last week. We have the div, which is this critical, absolutely critical element to HTML. It's how we nest things. It is the building block of websites. And then of course, headers and paragraphs, also extremely common. As a syntax review, you just start with your opening tag, put whatever contents you need inside it, and then close it off with a closing tag. And those contents can be text or they could be more elements themselves. I've also added a few IDs and classes. These are added using attributes in HTML, and they're nice for styling. So we'll see what that styling looks like below. Okay, so in our CSS section, we've done some styling. So each CSS chunk of code is made up of 3 building blocks. We have our selector, where we select what elements we want to style. The body, which we only mentioned briefly last week, will just help us style the background. The div selector styles all divs, H1 or H2 styles our H2s, and so forth. We also see that we have a couple other selectors, such as our class selector, which is we select with a dot. So this selects all of the class child elements on the screen. And then finally down here, we have our parent selector. The parent is actually an ID, which we select with a hashtag. As a reminder, an ID is a tag that we use to uniquely identify a single element, whereas classes we would use to identify groups of different elements that all fit into some sort of common group, that we want a common styling shared amongst them. So beyond the selectors, we also have within these curly brackets some properties and values. So for example, in the div, the things we want to style about our divs are we want a margin style, a padding style, a border, and a background color. And then of course we set those equal to whatever value we want on them. So notice here that we have in our div selector, the background color is set to green. So can anyone in chat tell me why the background of this div is not in fact green? And I will scroll down a little bit to give you guys a hint. So why is it that even though I have set the background color to green on my div, it's actually this like purple color? Yep, because of the ID, exactly. Specificity, ID rules, however you want to call it. So there is a hierarchy of these selectors, and it turns out that this ID selector actually has a higher priority, so it's going to override. So there's contradicting instructions in here. In one place, it says that the background color of divs should be green, and down here it says that the background color of this one particular div, ID parent, should be lavender. So if we added new divs on here without the ID, they would be green, or if we just got rid of this code altogether. So specificity, I'm glad you guys remembered that because that is a key idea in CSS. Finally, I want to bring up the JavaScript tag, or tab, not tag. So we're not, unfortunately, in this intro course, we won't have a lot of time to actually talk about how JavaScript really ties into web development. But since you have a little bit of JavaScript under your belt at this point, I wanted to talk about it a little bit. So how we use, we know on a high level how JavaScript might be used. So the JavaScript plays into web development by being the tool that allows our site to be dynamic. So we might be dynamically changing things about the style, or about changing the style, or changing what elements are on the screen, or even using it to process data and submissions and loading data on something that is data-oriented, like a social media app. What I wanted to show you here is that we have this method that we can use inside of JavaScript called query selector all. And this method exists on an object called document. We haven't worked with this object or this method yet because they don't really make sense in Replit. This method really only makes sense in more of a web development environment like we have here. But what query selector all does is it takes in one bit of input, the name of an element in HTML, and it will return out, it will resolve to all of the elements that match this. So right now this is resolving to, or spitting back out, all of the paragraphs on our page translated in a weird JavaScript form. And I know I'm going to go through this kind of quickly. You don't need to fully understand this. You won't need to be writing a query selector or anything like that. I just want to give you guys a taste of what this is all building up to. So I am going to save this into a variable called all-ps, not all-ps. And all-ps, I'll even capitalize. Okay, all-ps is going to contain all of the paragraphs that are on the screen in JavaScript form. And if we want to get a sense for what those look like, we can always console log them. Remember, because we're not in Replit, we can't just automatically see our last line of code. That's a Replit specific tool. But we can console log to see what we're working with. So if I open the console, once again, remember, we're not in Replit anymore, so we need to use our real console instead of the fake Replit console. So we look down, and this is what's been logged, is something called a node list. And once again, don't get too overwhelmed by this. You don't need to fully understand this. Just know that these things that are appearing in our console are JavaScript representations of HTML code. And we can even see that there's, let me pull this over. We can see that in the first one I dropped down, we can see the actual text represented. Or if I look at the second one, which is actually the third one, we see third paragraph. And the middle one has the text. So this is just a little window into what you guys will be working with in the main curriculum when you bring all these skills together. But let's not get too bogged down on that. I want to switch gears to JavaScript now. So just wanted to give you a little taste of the kinds of things that you'll be doing with JavaScript in the context of web development. And hopefully the craziness of what's appeared in the console has also given you a sense of why we're not working with those just yet. We're still building up to that type of coding. So let me put this away and move on into Replit so we can do a JavaScript review. All right, so let's start our JavaScript review with a little bit of a free-for-all in chat. Can you guys tell me the most interesting or most important or most random things that you learned about JavaScript last week? So total free-for-all. I want you to just shout out something interesting you learned. Loops. We'll definitely review those. Loops, variables, control flow. Definitely talked about that. Scope. Yeah, we'll be talking more about scope today. Scope is very important with functions. Side effects. Yeah. We'll also be talking a lot about methods today. Cool. Dry coding. Yes, we will be talking about that. Awesome. All right, I think you guys caught pretty much all the big topics. So let's do some reviewing of these, and some of these will just keep coming up, like things like dry coding, scope, side effects, whatever we're talking about that is relevant. So let's start out with variables. Variables are a good first topic. So actually, before we talk about variables, let's talk about types. I'm not sure if you guys even threw that out, but data types was one of the first things we learned, which is that we have things like strings, we have numbers, we have booleans, we have undefined and null, these weirdos that represent lack of data. So these were the most important types that we talked about last week. Strings being chunks of text or characters or symbols, numbers are just numbers. Booleans represent this either or category that's critical in programming, and they're represented with the idea of true and false, and undefined and null. So these are the basic building blocks of all code. We've been sort of briefly introduced to a more complex data type, which is that of the function, and we'll of course be talking a ton about functions tonight. So one of the most basic things you can do with these JavaScript types are to declare variables with them. So let's do const name equals, and let age equals 29. All right, so I've just declared variables using two different keywords, const and let. Can anyone tell me the difference between const and let? And can anyone guess at why I chose to use const for my name variable, but let for my age variable? So we have let can be muted. Age changes. Yeah, exactly. So presumably your name will not change over the course of your life, but your age most definitely will. Every year your age will increase. And if we were representing that in JavaScript, we might use our handy ++ operator to increase age by 1. So yes, that's the idea is that this there are two things going on here. There's a value that we're saving in memory. That's going to be on this side of the equal sign. So we're saving a string in memory here. We're saving a number in memory here. And then we're coming up with a label or variable name. So the idea is that on line 3 with const, this label and this value are bound together. They're stuck together. This label can't refer to another variable. Down here, age and the value 29 are not bound together. We can reassign age to a different value, like 30. And in some cases, it makes sense to have these bound. In other cases, it does not. So, and there's, of course, the var keyword, but I like to stay away from that. So both of these lines of code would be an example of code that has a side effect. The side effect being that we have just stored something in memory. So if we just wrote the word Amanda all by itself, this line of code has no side effect, because even though we've written out a string, once we're on to line 6, nothing has happened, nothing has changed. We created a string and then it blew away with the wind. However, line 3 does have a side effect because that name is stored in memory and we can access it using name. However, these lines of code or these chunks of code that don't have side effects, we can often think of them as resolving to something, like Amanda kind of redundantly resolves to the string Amanda. But what's nice about chunks of code that have side effects is we can group them together to build longer and more complex expressions. So for example, we might have a number which resolves to the number, or we might add numbers together. Getting more interesting, this all resolves to 21. We might throw this into math.round. Let's make it a decimal. This has a side effect too. So none of the things I've written here actually, none of the things I've written have side effects, but they all resolve to something. So we can keep piecing them together into bigger and more complex things. And then maybe eventually we store the value into a variable or do something else with it. Another option of a line of code we might use that does have a side effect is console log. The side effect being that something appears on the console. And we saw what the real console looked like just earlier in our, over here, when I console logged. So this is what the real console looks like. In Replit, it's mocked out. So anything in white represents the console. So that's the idea of side effects versus code resolution. Even though it was one of the first ideas I introduced you to, it's not a simple idea, and I'll keep bringing it up, but it is at the crux of understanding how the code really works. So what else did we talk about here? We talked about loops and control flow. So control flow is a broader term that refers to where does the code go? What lines are read? What order are they read in? Are any of the lines read multiple times? So one example of control flow, which I saw you guys mention, would be an if-else statement. So if a condition is true, you might do one thing. Otherwise, you might do something else. And of course, we don't normally hard code in a Boolean value here. We might plug in a variable here. Maybe this condition is coming from user input or some outside value. Or we could even compare something in here. And as we saw, we could even put in a string or a number in here, and it will obey the truthy-falsy rules. So that's an if-else statement. It's a way of giving two different options of how the code might run. It's basically a fork in the road. Another example of control flow is looping. If we wanted, instead of forking our code, if we wanted to actually run it on a circle, have the same line of code execute multiple times, we would use a loop for that. So we usually start a loop at 0, we tell it how many times we want to loop through, and then if it's just a standard loop, we'd probably be incrementing our counter I. And each time this runs, it's called an iteration. So we could run this and see all the loop iterations. So this line actually ran 10 times, with the value of I changing every single time. The value of I starting at 0 and ending at 9. And remember, we like to start our counting at 0 in programming. Tomorrow when we talk about arrays, you'll see another reason we do that. So yeah, so that is looping for you. And then a couple other things we mentioned here are dry coding, scope, methods. That stuff will all come up in tonight's lecture. So I think I'm gonna more or less call the review section of tonight, and we will switch gears to talking just about functions. So functions themselves are a data type in JavaScript. So I know I just briefly mentioned last week that there's this type of operator. So if we run our type of operator on a string, it'll tell us we have a string. If we ran it on a number, it would tell us we had a number. If we ran it on a function, such as console log, it would tell us we have a function. That's because a function is a new type in JavaScript. Or it's not new, but we haven't talked about it a ton. So the method console log and all methods belong to this broader category called functions. So first thing to remember is that all methods are functions. But the opposite is not true. Not all functions are methods. And we'll see some examples of functions that are not methods before tonight is up. So console log, math.random. If we have some string methods too. All of these are functions. And we can think of functions as being like a set of rules, or what I like to say is a recipe. So think about the actual recipe, whether it's a page in a recipe book or something written on a cardstock in your mom's handwriting or in your handwriting. That is what a function is like. It's like a set of rules. It's, to get more codey, you could say it's a script that exists somewhere off in memory that has yet to be executed. And so all of these examples of functions that we've done are like these set of rules, this untapped potential. Now, where functions get really interesting and meaningful is when you follow the recipe. In function terminology, that's called executing the function. So when we execute, it's like we've followed the recipe. So let's go back to, let's actually just use this toUpperCase example. So we see that word.toUpperCase is a function. This is like the untapped recipe. So can anyone tell me how I could change this? I'm going to get rid of type of. Change this line of code so that we're actually executing the function. I see the answer already. That is correct. We use the parentheses. And if you need a little memory tool, think of the parentheses as being like a button that you press when you want to execute the function. So now it's like the difference between going from having a recipe sitting on your kitchen counter versus going out, getting the ingredients, making the recipe and completing it, and now having a dish. So this line of code, can anyone tell me, this is a little tricky, but can anyone tell me what JavaScript type this line of code resolves to? I know that's a little tricky. A string. Yep. So you're right that the value is going to be word, all uppercased, but the type is a string. So without the parentheses, I'll even add this type of operator back in. Without the parentheses, function. With the parentheses, who knows? In this case, it's a string, but a function could resolve to undefined, it could resolve to a number, it could resolve to a Boolean, it could resolve to another function, which is kind of a weird thing we'll sort of talk about on Thursday. So we don't know. I mean, if in this specific case, we know it's going to resolve to a string because toUpperCase returns a string, but depending on the function, it could return anything. So keep that in mind. It's different whether or not we're working with the function or if we've called the function. So we say call the function or execute the function in order to run the recipe and get the results back out. Cool. So that is the basics of a function. The kind of first starting point to think about is the difference between the function itself and the function call. And that's not an easy concept. The next thing we want to think about, if we're going to stick with this recipe analog, is the ingredients. So the ingredients with respect to a function, there's two terms we might use. There's the parameters and the arguments. And also another tricky thing to keep track of what's the difference between these two. We can think of these both in general terms as the stuff we plug in. So that's what goes in the parentheses. So let's use toUpperCase does not actually have any ingredients. So this is where my analog falls a little short because recipes always have ingredients. But it turns out that functions don't always have arguments. toUpperCase works just fine when you pass stuff in. So let's look at an example of something that does. And I will use math.abs. So I don't know if we've talked about math.abs yet. It's just the absolute value function. So math.abs expects 1 bit of input. And you put in a number, and it will return out a number. So math.abs without the parentheses, function. With the parentheses, it's going to resolve to a number, which is spit back out. So for our argument, in this case, our argument was the number -3. So we think of arguments as being the term that describes what do we specifically put in this function call. So let's call it a few more times. And we'll only see the result of the last line because of replit. So in case 1, the argument was -3. In case 2, the argument was 10. In case 3, the argument was -2. So the argument is whatever value we're passing in. So it might change, the argument or arguments might change from function call to function call. Parameters is more of a general term. So we would say the parameter for math.abs is a number. So that applies for every single call. It's always a number, but it's more vague. So think of the parameters as being a term for, in general, what do we expect? Vaguely, what do we expect to go in our function? Whereas the argument or arguments are going to be what went in this specific case. So the value of the argument or arguments would change depending on the function call. And I'll go over that distinction a few more times. I know it's a little confusing. So we've talked about the input. Now the last thing we want to talk about is the return value, which is the output. So if we bring back math.abs, the return value for this is 3. The return value for that one is also 3. So the return value is the same as the code resolution. It's just that we use the term return value when we're talking about functions specifically. It's important enough to think about what a function resolves to that it has its own term. So, but in the case of functions, this and this are exactly the same thing. And the return value may not exist. And I think I saw a question pop up about console log. I think someone asked, does it have a side effect and a resolution? It does certainly have a side effect, but it does not resolve to anything. In other words, it resolves to undefined. That's what gets spit back out of our function. So these parameters and return values are an important part of understanding functions, but one thing to keep in mind is that some functions, like toUpperCase or math.random, have no parameters. Other functions, like console log, might have no return values. So I want you to always be asking, what are the parameters? What are the return values? But keep in mind that there may not be any. So that's a basic review of terminology. And so far, we've been playing exclusively with methods. And I know some of you guys are wondering what makes something a method specifically. And from a visual standpoint, methods are really easy to spot because they involve a dot. Console.log, math.random, string.toUpperCase. And the short answer of what, to say look for the dot is a convenient answer, but it doesn't really tell you what a method really is. The short answer is that the method somehow works with this object that's on the other side of the dot. Like, how does toUpperCase this value? That's because toUpperCase has knowledge of what this value is. Random has knowledge of all sorts of interesting things that are stored inside of this math object. Console.log has access to the console. These ones are a little weirder and vaguer about with these global objects, but in the case of the string, it's pretty clear that we are working with the string value in some way. And the result of toUpperCase is going to depend on which string is on the other side of the dot. So short answer, look for the dot. And on Wednesday night, we'll get a much deeper look into what methods really are and how they work. But for now, I would say mostly look for the dot. So let's look at some functions that are not methods, that don't have the dot. They're just regular run-of-the-mill functions. And it turns out that the best way to check out those kinds of functions are to actually create them ourselves. So we are going to be writing our first function together right now. And I'm going to start with a pretty simple function called add. All right, so let's start out with just looking at the syntax of this function. So in order to create a function, we use the keyword function. So keywords, glowing in blue, they are words that are built into the language that help us do stuff like const or true or undefined or function or for or if, all keywords in JavaScript. So we start with the keyword function. We then name our function. This is kind of like naming a variable. So this can be anything we come up with. We could have called it combine. We could have called it plus. I think add works just fine. We follow that with a set of parentheses. This is where we will define our parameters. The parameters are whatever user input we expect in order to run our logic, the ingredients. And then finally, we have the actual function body. This is where we will write our function logic, including defining what value we want to return. So this is the shell of a function. So for our add function, can anyone tell me what parameter or parameters we might expect an add function to have? A number? All right, you're close. 2 numbers. Okay, better. So 2 numbers, exactly. Yeah, and someone even suggested names for the parameters. I like it. A and B. I usually go with X and Y, but we'll do A and B. Or actually, I like this even better. A more sophisticated add function might have an unspecified number of parameters. Some functions do that. That's something we're allowed to do. We're not going to do that tonight because it's more complex, but just so you know, you could have an add function that you could put in as many as you wanted in, and they would all add together. We'll just do 2. So A and B, and these are our parameters because we're saying in general, what do we expect? Okay, so what do we want to do inside of our function body with A and B? Cool, you guys are way ahead of the curve. So I saw A plus B, which is a good starting point, but won't quite work. And I see the full answer elsewhere too. So we can actually, so let me explain this for those of you that aren't familiar with return statements. So we definitely want to add them up. So we can use A plus B, and whatever values are passed in for A and B will be added up here. But remember that A plus B on their own, if we just add 2 things together, there's no side effect to that line of code. So here's a new side effect for you guys to learn, and that's a return statement. The keyword return inside of the function scope, and we surely have function scope here. We'll talk about scope in a minute. Return will create a side effect where a value is spit back out of the function when it's executed. So return statements, really important when you're working with a function. So now that we've written our add function, let's call it. And we can see it works. Now 3 and 4 would be considered our arguments. So A and B would be our parameters. We expect 2 numbers, 2 random numbers. In this particular case where we called our function, the arguments were 3 and 4, the specific numbers. If we think about that recipe example I used, think about an argument as being, or sorry, a parameter as being the word 2 eggs written on a recipe. Whereas an argument would be the literal 2 eggs that you just pulled out of the carton and cracked to put in your whatever you're making. So that's the difference between parameters and arguments. I often mix them up. I'm sorry if I do that. It's not critical, you know the difference, but it's nice. It makes you a more sophisticated sounding coder if you can use those 2 terms correctly. So let's look at a few more examples. We might do something like say name. In this case, we are going to take in a name, and we'll just console log hi with the name. And then if we call say name, we see that, we see hi Alan appears. Let's capitalize that. That looks better now. Okay, so little pop quiz for you guys. What are in these this chunk of code, what is the argument for my say hi function or say name function, and what is the parameter when I call it? The argument is Alan, and the parameter is the name. Yeah, exactly. So the argument goes with the function call, the parameter goes with the function definition. Okay, can anyone tell me Does say name have any side effects? And does it resolve to anything? It resolves to, oh, I'm getting all sorts of answers here. So this is a tricky one. It does not resolve to anything. One way we can tell is that undefined appeared in green. Another way we can tell, since we can see in the function, is there's no return value. Remember, return values and code resolution are the same thing when it comes to functions. So if there's no return statement in here, we can be pretty darn sure it's not going to resolve to anything. However, the console log creates a side effect. So yes, this does have a side effect, but no, it does not resolve to anything. So yeah, and don't beat yourself up about it. There's a reason I keep bringing it up, and that's because it's really tricky, this idea. So one more example I want to show you is, let's write a function called getLoud. And you're going to put in a phrase, and we'll return phrase.toUpperCase plus a exclamation point. Okay, so if I say getLoud, all right, I'm not going to run it just yet. When I run this code, what will my function call resolve to? What will my function call return? Yep, learning about functions, all caps with an exclamation point. There it is. So we're taking the phrase, we're uppercasing it, we're concatenating on an exclamation point. That's just tacking one on the end. And now when we actually call the function, this logic in here executes. And we see our return value is the result of that logic. Yep, and you guys are right that the parameter is phrase and the argument is learning about functions. Nice job, guys. Okay, so the one last thing I want to talk to you about in terms of writing functions is there are actually there's another way to write a function. There are a couple other ways to write a function. I'll just show you one. So first I want to introduce you to a term called anonymous function. So if we wanted to create an anonymous function that does the same thing as getLoud, notice this would be the anonymous version. And it's pretty straightforward. It looks exactly like that version we wrote above. It's just missing a name. So that is what's called an anonymous function. And we'll see a handful of use cases for those as we go through the rest of this week. However, it turns out that an anonymous function just hanging out on its own like this is not allowed. And if I try to run this code, we get a syntax error. So anonymous functions on their own don't work. But let me show you one thing we might do with an anonymous function, which is store it into a variable. So we can actually declare a variable with the name of our function and store and assign in an anonymous function. This code and the code I commented out up here are almost identical. They both create a function that does exactly the same thing. They're almost identical. They're two different ways of doing the same thing. One difference has to do with hoisting, which I mentioned ever so briefly last week. So if I try to call getLoud, if I try to call getLoud above where I declared it using this variable declaration style, I will get type error. GetLoud is not a function because this assignment hasn't happened yet. Remember, assignments are not hoisted. And don't worry too much about the hoisting thing. Practically speaking, just know that you can't call getLoud above this function. However, if I comment this out and bring this version back, because there's no assignment going on, this whole line of code will be hoisted, which means it will be run in advance of everything else. So it turns out that this is allowed. So you don't need to deeply understand what this hoisting thing is. Just know that if you use the function keyword and name your function, you can call it wherever you want on the page. If instead you write an anonymous function and assign it into a variable, that little fun rule no longer applies. So beyond that, just practice writing functions in both styles. Another way you might write functions is the arrow function syntax, which I will not be teaching, but you are welcome to Google if you are curious about. The arrow function syntax is nice for really simple functions. Okay, so that is how you declare functions. We talked about arguments and parameters. Let's talk a little bit more about, actually, let's talk about scope. So I mentioned scope briefly, but then I didn't come back to it. So remember with if statements or for loops, how whenever we used these little curly brackets, we created something called scope. It was like a whole new ecosystem where the rules were slightly different. And one of these rules is that different keywords are allowed. Like the return statement only works inside of a function scope. Don't try and return outside of a function scope. You'll get return outside of a function. That's actually an extremely straightforward error message. Not allowed. The other rule has to do with variables that are declared inside of scope. If I declare a variable out here, we'll just call it global. Oops, global is a reserved word. We'll call it, why is it glowing and I don't know what Replic's doing, but we'll just call it global scope and set it equal to, how about true? So we can use this inside of our add function if we want. Because anything declared in global scope can be used in here. So if we run add, what did I do? Oh, you can't have the function declaration twice. There we go. So this console log worked because this variable is accessible inside of my local scope in here. And I can, in fact, even reassign it in here if I want. Oops. And that's allowed too. And it will still be accessible down here if I want as well. So because I declared it globally outside of the curly brackets, I can use it inside of the local scope. I can reassign it. It will all stick. But if I did something else, let me get rid of some of these console logs. Let's say that I decided to split this one line of code into two. So I said const C equals A plus B, and then we returned C. So these two lines of code did the same thing that the last line of code did. It still works. But now I have a variable called C that's been declared inside of local scope. So if I try to access C outside, I get a reference error. C is not defined. So this variable is only usable inside of this scope. And it turns out that the same is true of my parameters. If I tried to console log A, I would get A is not defined because these two variables will only exist as long as we are inside of the function call. So that is a little review of scope and also a little insight into how scope applies to variables specifically. The biggest takeaways, or sorry, for functions specifically, the biggest takeaways are that these parameter variables are not going to be accessible outside of the function scope. Any other variables declared inside of a function are only accessible inside of the function. The return keyword is only usable inside of a function. And furthermore, this shows us the importance of the return statement, because if there's no other way to get value, there's no other way to get these values back out. We can do some hacky stuff by declaring a variable out here and reassigning it, but we don't like that. What you really want is that whatever your result is, whatever you want as your final result of your logic inside of your function should be spit back out with the return statement. That is the way of reaching back out of scope and giving the global scope a little token of what happened inside of the function statement. So the last thing I want to talk about with these functions are return statements. There's a little bit more to them than meets the eye. So let's spend some time looking at that. I'm going to wipe the slate clean. Let's do a little if-else example. And we can use, these things are all stackable. So we can have if else statements inside of functions. We can have for loops inside of functions. You'll see examples of all those on the homework tonight. So let's do a function called can drive, and it's going to take in an age. So if blank, let's do return true. So else, let's return false. Okay, so first a little if review. What condition do you think? So this function should determine if someone is legally allowed to drive or not based on their age. So what condition do you think should go inside of this if else statement? All right, I see greater than equal to 16, almost. Age, yep. So if age is greater than or equal to 16, perfect. It's true, otherwise it's false. Let's make sure it works. 12, false, it's good. Probably don't want 12-year-olds on the road. True, we may or may not want 18-year-olds on the road, but you know, we all got to drive when we were 18, so we have to put up with them now. Okay, so here is my question for you guys. Does this function have multiple return values? What do you think? All right, I'm getting a mix of yes and no. Okay, so this is kind of a trick question, so I don't blame you guys. So a function can only have one return value. There's only one thing that it can spit back out. So in this case, with this argument, the return value is true. With this argument, the return value is false. So the return value may change based on the argument, but there's only ever one return value per function call. However, there are two return statements in here, but notice that only one ever runs in any case. So in some cases, line 9 runs, in some cases, line 11 runs, but you can only ever have one return value. So you might have multiple return statements to create options, such as with an if else, but there's only one return value. So if I got rid of my conditional and just wrote this code, and I'll call this mult returns. Okay, what do you think? This is tricky. What do you think this function will return? Because there can only be one return value. We have a bunch of different guesses. Some people think there's an error. Some people think it's true. No one seems to think it's false. So it won't error out. It will return true. So whenever it hits a return statement, it's done. It just stops. It does not care what is below. So if you do, for some reason, write multiple return values or return statements, any below will be ignored. The first one is the only one that will be read. So, and that doesn't just go for return statements. So this console log will never run, even if we got rid of our second return statement. Any logic below the return statement will be ignored. So unless it's in a conditional, your return statement should always be at the very bottom of your function code. This is extremely common pitfall when you're first learning functions. Is you're trying to debug, you throw a console log in, you don't know why your console log's not appearing, everything feels broken. It's probably because the console log is below the return. See, no console log. If I just move the console log above my return statement, all is good. So all logic needs to be above the return statement. Yep, and so I like someone just said in the chat channel, so if you have multiple returns, the code can work, but not do anything useful. You'll see that a lot in JavaScript. JavaScript is kind of a loosely defined language in that it will throw errors, but it'll try to make sense of what you wrote. It's flexible. You know, if you ever program in something like Java or C, one little thing's out of place and it's not going to run your code. JavaScript will do its best to figure out what it thought you meant, for better or worse. It can be nice because there are less errors. It can be obnoxious because you can't figure out why your code's broken, because instead of erroring it out, it just made its best guess. So if you have multiple returns, it'll just say, oh, we think you meant the first one. So that's a little fun quirk of JavaScript. Love it or hate it. I personally am kind of a fan of the more strict style of languages, but some really hilarious things happen in JavaScript, so that makes up for it. All right, well, that is everything I have to show you with functions. Let's go over the homework real quick. So we have just one assignment for tonight. It will be all about writing functions. So I'm just gonna copy over the first question here, just so we can check it out. So each question will be in this form. There will be an empty function shell and a description of how this function is supposed to work. And it's your job to write what goes in here. So let's do this one all together. How is this add one function supposed to work? Actually, I'll go over here to simulate the real homework. So we definitely want to add one to our x. And of course, we need a return statement. Really easy rule of thumb. If I use the word return in the description, you need a return statement. If I don't use the word return, you do not need a return statement. So what's interesting is when we run the code, nothing happens. When we run our tests, it will tell us that add one is working. So what happens if let's say we did add one plus plus? That seems like that should work, right? Turns out it doesn't. So if we had written this, we can't figure out, and this one's I'm not gonna tell you why this doesn't work. It's a little tricky to figure out why this doesn't quite do what we think it does. How would we test this code? Well, a recommendation might be we do add one and let's plug in, just pick any old example. You can pick the value from the example if you want. Then you'll be positive of what it's supposed to return. And so we have to call the function. And this is just, you don't need this to pass the homework. This is just a good way to debug the homework. And you might console log the function call. So in order to debug, I would recommend actually calling the function. You might even call it multiple times with multiple parameters, and then press run. Oh, sorry, add one. And then you press run, and you can see that add one is returning the same value we put in. So something somewhere has gone wrong. So I'll leave it up to you guys if you want to figure out why that bit of code doesn't work. But it doesn't. So this at least gives us a hint of like, okay, well, the adding isn't actually happening. So what do I do about that? Turns out a way to fix this would be to separate them. And then if we run it, we see it's working. So if you want to, you can just write code inside of these functions, run the tests, see which ones are working. But it might be nice if you're trying to figure out why something's broken to actually call the function and console log the result. But you don't need to call the function. That's not required for the homework. All right, so the last thing I want to mention with the homework, and keep in mind, you might be writing if statements in here, you might be writing loops, you'll actually have to write if statements and loops. All those things can go inside functions, just remember to tab them over. So I just wanted to talk about this one last problem before we go on to questions. So as I sort of mentioned at the beginning, I did this little mention of how JavaScript ties into HTML. And while we won't be doing much of that this week, I have some homework assignments that will allow you to start to think about that. For example, this getHTML tag function. So this is JavaScript code. We're thinking about HTML code, but this is actually JavaScript code we're writing. So all the JavaScript rules apply. GetHTML tag will take in a string and it will return out a different string. So on the surface, this is just all about manipulating strings. But it also has to do with HTML in that we're creating strings that look like HTML code. So you want to keep HTML code in mind because we're mocking it out with JavaScript, but don't overcomplicate it. This isn't HTML, we're just doing string manipulation. But this kind of string manipulation will help you think about how to tie JavaScript into these other languages. And you'll see more of that this week on the homework. All right, that's all I have for you guys. I will answer some questions. Please try to put the questions in the actual Q&A section in Zoom, and then I will let you guys go and work on this. Any questions, you guys? All right, so I'll give you like 30 more seconds. Otherwise, I'm going to interpret this as you trying to collectively tell me that you're done listening to me talk and you want to write some code. Okay, the people have spoken. No questions for tonight. So as always, if questions pop up as you are working on this homework, please first Google. I don't think I told you to Google once today. I'm totally ashamed of myself for that. But please Google. And then if Googling doesn't work, I would recommend you ask around, ask your fellow classmates, ask the TAs in Slack. And if that still doesn't work, you're always welcome to message me directly. I do recommend that you wait until you've actually tried the problem. If you're really stuck, though, please reach out to me and I will help you with it. So that is it for tonight. Tomorrow, we're going to be talking all about arrays and objects in JavaScript, two really cool types that we can use to cluster items together. So until then, have fun with the homework, and I will see you guys tomorrow.